The screaming dive of the Nakajima B-5N Kate torpedo bomber shattered the morning calm of Pearl Harbor at 7:53 a.m. on December 7, 1941. Commander Mitsuo Fuchida watched through his cockpit window as the first wave of his attack group descended upon the unsuspecting American Pacific Fleet like vengeful hawks. Explosions blossomed across Battleship Row in brilliant orange flowers of destruction, each detonation a symphony note in what he believed would be America's funeral march. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. Tora, 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 he radioed back to the carrier Akagi, confirming complete tactical surprise. The American battleships USS Arizona, USS Oklahoma, and USS California were already listing heavily, their massive hulls torn open by armor-piercing bombs converted from naval artillery shells. Black smoke billowed thousands of feet into the pristine Hawaiian sky, and Fuchida allowed himself a moment of satisfaction. Admiral Yamamoto's plan was working perfectly. But 3,000 miles away, in the emergency session of Congress that would declare war on Japan, Senator Harry Truman of Missouri was already thinking beyond the immediate devastation. While President Roosevelt spoke of a date which will live in infamy, Truman was calculating production capacity, steel tonnage, and the industrial might that Japan had just awakened. The Empire of the Rising Sun expected a 6-month war, a swift knockout blow followed by a negotiated peace that would leave them masters of the Pacific. They had no idea they had just poked the sleeping giant of American manufacturing. Within 18 months, the United States would not only replace every ship lost at Pearl Harbor, but would commission 12 new Essex-class fleet carriers, floating cities of steel that would carry the war back to Japan's doorstep with unprecedented fury. This is the story of that impossible transformation, told through the eyes of the men and women who turned industrial blueprints into maritime thunder, who worked around the clock in shipyards from Norfolk to San Francisco, and who proved that American democracy, when fully aroused, possessed a power that no empire could withstand. The mahogany conference table in the Navy Department building stretched like the deck of a battleship, its polished surface reflecting the grim faces of America's senior naval leadership. Secretary of the Navy Frank Knox sat at its head, his normally ruddy complexion ashen as he reviewed the damage reports from Pearl Harbor. The morning of December 8, 1941, felt like the dawn of a new and terrible world. "Gentlemen," Knox began, his voice steady despite the magnitude of their loss, "we must face facts. The Pacific Fleet has been crippled. 18 ships sunk or damaged, nearly 2,400 Americans dead, and our forward base in shambles. The Japanese have achieved tactical surprise on a scale not seen since Port Arthur." Admiral Ernest King, soon to be named Commander-in-Chief of the U.S. Fleet, leaned forward with characteristic intensity. His steel-gray eyes swept the assembled officers as he spoke. "The question before us isn't how this happened. We'll have time for that reckoning later. The question is what we do next. Japan believes they've bought themselves 6 months to consolidate their conquests in Southeast Asia and the Dutch East Indies while we lick our wounds."
Captain William Bull Halsey, one of the few senior commanders whose carriers had been at sea during the attack, slammed his fist on the table. 6 months, hell. Give me the ships and I'll take the fight to them in 6 weeks. "Ships," repeated Admiral Harold Betty Stark, Chief of Naval Operations, with bitter irony. "That's our problem, isn't it, Bill? Half our battle line is sitting on the bottom of Pearl Harbor, and the other half is in the Atlantic dealing with Hitler's U-boats." Knox pulled out a manila folder marked Top Secret and spread its contents across the table. Engineering blueprints, production schedules, and industrial capacity reports covered the mahogany surface like battle plans for a war of factories rather than fleets. "This is why I've called you here," Knox said, his voice gaining strength. "Before Pearl Harbor, we had already begun expanding our naval construction program. The Two-Ocean Navy Act authorized unprecedented shipbuilding, but the timelines were measured in years, not months. Now we need to compress that timeline by any means necessary." The man who would make that compression possible sat quietly at the far end of the table. Henry Kaiser was not a naval officer, but a civilian contractor whose construction company had built dams, bridges, and highways with unprecedented speed and efficiency. At 59, his round face and wire-rimmed glasses gave him the appearance of a small-town banker rather than an industrial revolutionary. But behind those mild eyes burned the vision that would transform American shipbuilding forever. "Mr. Kaiser," Knox addressed him directly, "your Liberty ship program has shown remarkable promise in producing cargo vessels quickly and efficiently. We need that same innovation applied to warships, specifically aircraft carriers." Kaiser adjusted his glasses and studied the blueprints spread before him. The Essex-class carrier design represented the pinnacle of naval engineering. 27,000 tons of steel formed into a floating city capable of launching 90 aircraft against enemy targets. Traditional shipbuilding methods would require 3 to 4 years to complete such a vessel. "Secretary Knox," Kaiser replied in his measured Midwest accent, "I've built ships in 80 days that the Maritime Commission said would take 300. The key isn't just speed, it's rethinking the entire process. Prefabrication, assembly line techniques, welding instead of riveting. We can revolutionize naval construction the same way Henry Ford revolutionized the automobile." Admiral King raised a skeptical eyebrow. "Mr. Kaiser, with respect, a carrier isn't a cargo ship. The complexity of the propulsion systems alone is a challenge we'll overcome through innovation." Kaiser interrupted politely but firmly. "Admiral, may I share a story? When I was building the Oakland-San Francisco Bay Bridge, every expert told me it was impossible to complete in the timeline we'd promised. They said the depth of the water, the seismic requirements, the sheer scale, all of it was beyond conventional construction methods. But we didn't use conventional methods. We invented new ones." He stood and walked to the large window overlooking the Potomac River, where the Washington Navy Yard's cranes were already working around the clock. "The Japanese made a fundamental miscalculation at Pearl Harbor. They destroyed ships, but they left our shipyards intact. More importantly, they underestimated the productive capacity of American industry when fully mobilized. Give me the resources, the authority to cut through red tape, and the cooperation of the Navy Department, and I'll deliver carriers faster than the Japanese can sink them." Captain John McCain, father of the future senator and grandfather of another, spoke up from his position as head of the Navy's Bureau of Aeronautics. "The aircraft production is already ramping up. Grumman, Chance Vought, Douglas, they're all converting to wartime production. But carriers without planes are just expensive targets, and planes without carriers are land-based assets with limited range." "Which brings us to the strategic picture," Admiral King interjected, unrolling a large map of the Pacific Ocean. The vast expanse of blue was dotted with islands, many now flying the rising sun flag of Imperial Japan. "Japan's grand strategy depends on establishing a defensive perimeter from the Aleutians to the Marshall Islands, then west to the Dutch East Indies. They're betting we'll exhaust ourselves trying to crack that perimeter and eventually sue for peace." Knox studied the map intently. "What they don't understand is that we're not going to assault their perimeter. We're going to bypass it. Island-hopping campaigns supported by fast carrier task forces. But that requires more carriers than we currently possess, and it requires them quickly." The meeting continued for 3 hours, with detailed discussions of steel allocation, shipyard capacity, and the unprecedented coordination required between government and private industry. By the time it concluded, the basic framework of what would become the greatest naval construction program in human history had been established. As the officers filed out, Knox retained Kaiser for a private conversation. "Henry," Knox said, using the contractor's first name for the first time, "I want you to understand what we're really asking. The Essex-class program calls for 12 carriers initially, but that's just the beginning. If this war continues as we expect, we'll need 20, 30, perhaps 50 carriers before it's over. Can American industry really deliver on that scale?" Kaiser smiled, the first genuine smile he'd shown all morning. "Frank, you're thinking like a traditional naval officer. 12 carriers, built one at a time in specialized naval shipyards. But what if we built them the way we build automobiles? Multiple yards, standardized components, interchangeable parts. What if instead of 12 carriers, we planned for 50 from the beginning and designed our production system accordingly?" Knox felt a chill of anticipation run down his spine. "You're talking about industrializing naval warfare itself?" "Exactly," Kaiser replied. "The Japanese are fighting the last war, naval battles decided by individual ship actions and superior tactics. We're going to fight the next war, industrial conflicts decided by productive capacity and resource allocation. They've trained for decades to outfight us ship for ship, but they can't outproduce us, and production is going to win this war." The two men shook hands, sealing an agreement that would reshape not only the Pacific War, but the fundamental nature of naval power itself. Margaret, Maggie Sullivan, had never seen the inside of a shipyard before December 15, 1941, but she could already hear the future singing in the clash of steel on steel. Standing at the gates of the Newport News Shipbuilding and Dry Dock Company in Virginia, she clutched her new worker identification card and listened to the symphony of American industry awakening to war. The attack on Pearl Harbor had changed everything for the 23-year-old former schoolteacher from Richmond. Like millions of American women, she had felt the call to contribute something more substantial than rolling bandages and planting victory gardens. The want ads in the Richmond Times-Dispatch had been specific. Women workers needed, will train, essential war work, good pay. The shipyard was hiring anyone willing to learn, and Maggie Sullivan had always been willing to learn. Her supervisor, Joe Martinez, was a weathered man of 50 whose calloused hands told the story of 30 years in steel construction. He met her at the personnel office with a mixture of skepticism and resignation that she recognized from her teaching days, the look of someone forced to work with unfamiliar materials. "Ma'am," he said, tipping his hard hat respectfully, "I gotta be honest with you. This ain't school teacher work. We're building the USS Hornet here. That's a 27,000-ton aircraft carrier, not a rowboat. The work is dangerous, dirty, and demanding. You sure about this?" Maggie looked past him to the massive hull taking shape in Dry Dock 10. The carrier's steel skeleton stretched nearly 900 feet from stern to stern, already bristling with the framework that would support its flight deck, hangar bays, and island superstructure. Hundreds of workers swarmed over the structure like determined ants, each one contributing to something far larger than themselves. "Mr. Martinez, I taught 8th grade mathematics for 3 years. I've handled everything from algebraic equations to adolescent hormones. I think I can manage steel plates." Despite himself, Martinez cracked a smile. "Fair enough, but the steel plates don't argue back when you try to teach them something." He led her through the yard's main gate, past signs warning of the penalty for photographing military construction and reminding all workers that loose lips sink ships. The scale of the operation was overwhelming. Multiple carriers in various stages of construction, thousands of workers organized into specialized crews, and the constant movement of cranes lifting massive components into place. "The thing you gotta understand," Martinez explained as they walked, "is that we're not just building ships anymore.
We're building them faster than anyone thought possible. Before the war, it took us 4 years to complete a carrier. Now the Navy wants them in 18 months, and Mr. Kaiser thinks he can do even better than that." They paused at the edge of Dry Dock 10, where welders were attaching hull plates with showers of brilliant sparks. The noise was deafening. Pneumatic hammers, steel cutting torches, the rumble of overhead cranes, and the constant shouting of instructions between work crews. "That's where you'll be working," Martinez said, pointing to a section where women workers were installing electrical systems. "It's precision work that requires patience and attention to detail." The Navy folks were skeptical about hiring women for technical jobs, but it turns out you're better at some of this stuff than the men.
Maggie's first partner was Betty Richardson, a former telephone operator from Norfolk who had been at the yard for 2 months. Betty was installing junction boxes for the carrier's internal communication system, threading dozens of different colored wires through conduits that ran throughout the ship's superstructure. As they walked along the carrier's hangar deck, Chin continued his explanation. "But the most important change is psychological. Before the war, shipbuilding was considered a craft. Master shipwrights passing down specialized knowledge to apprentices over decades. Now we're treating it as an industrial process that can be systematized, standardized, and scaled up. We're applying mass production principles to naval construction." The tour concluded at the carrier's flight deck, where workers were installing the arresting gear that would catch landing aircraft. The deck stretched nearly 3 acres, larger than most city blocks, and would soon support operations by 90 fighters, dive bombers, and torpedo planes. "When this ship is commissioned," Chin said, "it will carry more firepower than entire armies possessed just 20 years ago. And we're building 12 of them initially, with more planned if the war continues." The Japanese attacked Pearl Harbor, believing they were fighting the American Navy as it existed in 1941. They don't yet understand they're actually fighting the American Navy as it will exist in 1943. That evening, Maggie wrote her first letter home since starting at the shipyard. Sitting in her small apartment overlooking the Elizabeth River, she tried to capture the magnitude of what she was witnessing. "Dear Mother, I know you worry about me working in the shipyard, but I want you to understand what's happening here. We're not just building ships. We're building a new kind of naval power that the world has never seen. The Japanese may have won the first battle, but they've awakened something that will overwhelm them with its sheer productive capacity. I'm proud to be part of it." Through her window, she could see the lights of the night shift beginning their work, the sparks of welding torches creating constellations against the dark hull of the USS Hornet. The ship was still months from completion, but already she could envision it steaming across the Pacific, its flight deck crowded with aircraft preparing to strike back at the empire that had dared to attack America at peace. The telegram arrived at Henry Kaiser steel mill at 3:17 a.m. Pacific time on December 20, 1941. "Urgent. Stop. Washington meeting December 22nd. Stop. Bring production estimates. Stop. Knox." Kaiser read it twice, poured himself a cup of coffee from the pot that seemed permanently percolated in his site office, and began making phone calls. By dawn, he had assembled his core team of engineers, production managers, and logistics coordinators for an emergency planning session. The conference room overlooking the blast furnaces was thick with cigarette smoke and the intensity of men accustomed to solving impossible problems under crushing deadlines. "Gentlemen," Kaiser began, spreading Navy blueprints across the conference table, "Washington wants to know if we can build Essex-class carriers faster than traditional naval yards. Not just faster, dramatically faster. They're talking about 12 carriers in the time it would normally take to build 3. Chief Engineer Clay Bedford, a lean Texan who had supervised dam construction across the West, studied the carrier blueprints with the methodical intensity he brought to every new challenge. At 45, he had already revolutionized concrete construction and bridge engineering.
Now he was being asked to revolutionize naval architecture. "Boss," Bedford said after 20 minutes of silent review, "this is the most complex engineering project I've ever seen. Flight deck, hangar bays, aircraft elevators, catapults, arresting gear, island superstructure, propulsion plant, electrical systems, armament, armor protection. Every component has to integrate perfectly with every other component." "Complexity is just another engineering problem," Kaiser replied. "What concerns me is the timeline. Traditional shipyards build carriers like medieval cathedrals, craftsmen working for years on individual masterpieces. We need to build them like factories build automobiles. Standardized components assembled by trained workers using industrial processes." Production manager Mike O'Brien, a former Ford Motor Company supervisor, leaned forward with obvious excitement. "Henry, I've been thinking about this since we got the preliminary contracts. The Navy's been approaching carrier construction all wrong. They're treating each ship as a unique project. But look at these blueprints. 90% of the components are identical from ship to ship."
He pulled out a sheaf of manufacturing diagrams, covered with his own annotations. The hull sections, the compartment layouts, the machinery installations, they're standardized, but being fabricated individually. What if we treated carrier construction like automobile assembly? Mass-produce the components, then bring them together for final assembly. Kaiser's eyes lit up with the kind of enthusiasm that had built dams across rivers that engineers said were unbridgeable. "Walk me through it, Mike. How would automotive-style production work with naval construction?" O'Brien stood and moved to the blackboard, sketching a manufacturing flowchart that looked more like a factory diagram than a traditional shipyard layout. "Step 1, we establish multiple production lines for major components. Hull sections fabricated in Building A, propulsion units assembled in Building B, island superstructures constructed in Building C. Each building specializes in one type of component but produces dozens of identical units." He drew connecting lines between the buildings, indicating material flow patterns. "Step 2, we use the largest cranes ever built to transport these prefabricated components to final assembly areas. Instead of building the entire ship in one location, we bring the major components together and assemble them like a giant three-dimensional puzzle." Bedford interrupted with a technical question. "Mike, the structural loads are enormous. A carrier's flight deck has to support aircraft weighing up to 15,000 pounds, landing at 150 miles per hour. The structural engineering for prefabricated assembly is challenging, but not impossible," O'Brien replied. "We use the same principles that work for skyscraper construction. Steel framework designed for precise tolerances, welded joints that are actually stronger than the original riveted construction, and stress distribution calculated to handle dynamic loads far exceeding static requirements." Kaiser walked to the window overlooking the Fontana furnaces, where molten steel was being poured into molds 24 hours a day. "The steel production is the foundation of everything else. We're already producing more steel than any facility in history, but carrier construction will require specific grades and alloy compositions. Can we retool for naval specifications without disrupting current production?" Metallurgy supervisor James Wong, a Chinese-American engineer whose expertise had been crucial to Kaiser's dam projects, consulted a thick folder of technical specifications. "Mr. Kaiser, the Navy requires high-tensile steel for hull plates, specialized armor steel for protection, and corrosion-resistant alloys for marine environments. We can produce all of these grades, but it will require dedicating specific furnaces to naval production. I estimate we can meet 60% of the steel requirements for 12 carriers within our current capacity." "And the other 40%?" Kaiser asked. "Partnership with other steel producers or expansion of our own facilities?" "Given the timeline constraints, partnership makes more sense.
Bethlehem Steel, Republic Steel, U.S. Steel, they're all ramping up military production. We coordinate specifications and share the load. The morning session continued with detailed discussions of every aspect of carrier construction, from the specialized elevators that would lift aircraft between hangar and flight decks, to the complex radar systems that would guide defensive fighters to intercept incoming attacks. Each system required its own supply chain, its own specialized workforce, and its own quality control procedures. After lunch, the team tackled the human resource requirements. Building 12 carriers simultaneously would require a workforce larger than most American cities. Welders, electricians, machinists, crane operators, engineers, inspectors, and hundreds of other specialized trades. We're talking about hiring and training 50,000 workers in 6 months, said Sarah Mitchell, one of the few women in Kaiser's senior management team. Most of them will have no previous shipbuilding experience. We're essentially creating a new industrial workforce from scratch. Kaiser nodded grimly, which brings us back to the fundamental question: can it be done? Not theoretically, but practically, given the constraints of materials, labor, and time.
The room fell silent as each team member mentally reviewed their area of responsibility. These were people accustomed to achieving the impossible, but the scale of what they were contemplating dwarfed even Kaiser's previous achievements. Finally, Bedford spoke up. "Henry, I've built dams that everyone said couldn't be built, bridges that everyone said would fall down, and industrial facilities that everyone said were too complex. Every time, the key was breaking the impossible project into possible components, then solving each component systematically." He moved to the blackboard and began sketching a project timeline. "Here's what I think we can do. We established 3 major carrier construction facilities: California, Oregon, and a partnership facility on the East Coast. Each facility specializes in different aspects of construction, but shares standardized components. We aim for 1 carrier launched every 6 weeks from each facility once full production is achieved." O'Brien added his own calculations. "That timeline assumes perfect coordination between facilities, no major supply disruptions, and a learning curve that improves efficiency over time. It's aggressive, but not impossible." Kaiser studied the timeline, mentally calculating resource requirements and potential bottlenecks. "Gentlemen and lady," he said with a nod toward Mitchell, "I believe we can do this. More than that, I believe we must do this. The Japanese have given us a 6-month head start while they consolidate their conquests. When that 6 months is over, we need to have naval superiority in the Pacific, or this war could last a decade." The meeting concluded with specific assignments for each team member. Bedford would oversee facility design and construction, O'Brien would manage production processes, Wong would handle materials and metallurgy, and Mitchell would organize the massive workforce recruitment and training program. As the team dispersed to begin their individual preparations, Kaiser remained in the conference room, studying the carrier blueprints one more time. The Essex-class design represented the pinnacle of naval architecture, a ship capable of projecting American power across 8,000 miles of ocean to strike at the heart of the Japanese Empire. But looking at those blueprints, Kaiser saw something more than a warship. He saw the physical manifestation of American industrial democracy, the transformation of raw materials into instruments of strategic power through the coordinated efforts of free citizens working together toward a common goal. The Japanese had attacked Pearl Harbor believing they were striking a fatal blow against American naval power. What they had actually done was awaken the greatest productive force in human history. Within 18 months, the arsenal of democracy would be launching a new carrier every 6 weeks, each one carrying 90 aircraft and 3,000 crew members trained for one purpose: bringing the war back to Japan with compound interest. Kaiser picked up the telephone to place a call to Washington.
Secretary Knox would have his answer within 48 hours, and that answer would reshape the balance of power in the Pacific.
The Enterprise had been at sea when Pearl Harbor was attacked, sparing her from the devastation that befell the battle line. Now she and her sister ship, Hornet, were essentially the only fleet carriers available for offensive operations in the Pacific. The weight of America's naval response rested on these two ships and their irreplaceable air groups. Lieutenant Commander John "Jimmy" Thatch, the Enterprise's air group commander, joined the discussion in the flag plot. His weathered face showed the strain of constant operations, but his eyes held the fierce competence of a naval aviator at the top of his profession. "Admiral," Thatch said, "I've been thinking about this production program from a tactical perspective. Even if Kaiser can build carriers quickly, where are we going to get the pilots to fly off them? It takes 2 years to train a competent carrier pilot from scratch, longer if you want them to survive combat against experienced Japanese aviators." Halsey nodded grimly. "That's exactly my point, Jimmy. The Japanese have been training carrier pilots since the early 1930s. Their air crews at Pearl Harbor were veterans with thousands of hours of experience. We're talking about replacing that expertise with factory workers who've never seen salt water." Browning consulted another set of reports. "According to these Navy Department estimates, we'll need to train approximately 15,000 new pilots for the expanded carrier fleet. That's more pilots than the entire Navy had before the war began." 15,000, Halsey repeated slowly. "And every one of them has to learn carrier operations, night landings, formation flying, navigation over empty ocean, dive bombing, torpedo attacks, air-to-air combat. The Japanese shoot down green pilots like ducks on a pond." The conversation was interrupted by the arrival of Commander Joseph Jocko Clark, commanding officer of the USS Hornet. Clark had brought his ship alongside the Enterprise for a conference on the upcoming Marshall Islands raid, and his perspective added another dimension to the discussion. "Bull," Clark said, reviewing the same production reports, "I understand your concerns about training and experience, but we can't fight this war with the 2 carriers we have now. The Japanese have 6 fleet carriers and are building more. If we don't expand our forces dramatically, we'll be overwhelmed by simple numbers." He pulled out intelligence estimates of Japanese naval construction. "According to our best information, they're converting passenger liners and building light carriers as fast as they can. They understand that carrier warfare is about mass as much as individual ship quality." Halsey studied the intelligence reports with professional interest. "Joe, the difference is that their converted carriers are operating with experienced air crews. Our new carriers will be manned by pilots who learned to fly last week and sailors who think the pointy end goes forward." The debate continued as the Enterprise task force approached the Marshall Islands. Below decks, the ship's company was preparing for action. Armorers loading bombs and torpedoes, mechanics checking aircraft engines, and pilots studying target photographs and approach routes. In the ready rooms, the tactical realities of carrier warfare were brutally apparent. The Enterprise could launch 42 aircraft for the Marshall Islands strike, 18 dive bombers, 12 torpedo planes, and 12 fighters for escort. It was a respectable strike force, but nothing compared to the 350 aircraft armadas that would soon be launched from the new Essex-class carriers. Lieutenant Commander Wade McCluskey, commanding the Enterprise's dive bomber squadron, gathered his pilots for a final briefing before launch. These men represented the core of American carrier aviation, experienced professionals who had survived the early months of the Pacific War through skill, courage, and tactical innovation. "Gentlemen," McCluskey said, pointing to reconnaissance photographs of Kwajalein Atoll, "we're hitting shipping and shore installations. The Japanese have approximately 30 aircraft based on the island, mostly land-based bombers and fighters. Expect heavy anti-aircraft fire and aggressive fighter opposition." One of his younger pilots, Ensign George Gay, raised his hand. "Skipper, the scuttlebutt is that we're getting dozens of new carriers in the next year. Does that mean operations like this will get easier?" McCluskey considered the question carefully. "Ensign, more carriers means more firepower, but it also means more complexity.
coordinating strikes for multiple carriers, managing air traffic over the task force, integrating new pilots with different training backgrounds. It's going to require tactical innovation on a scale we've never attempted.
He gestured toward the ready room's tactical displays. Right now, we operate as a single unit. Everyone knows everyone else. We've trained together for months, and our procedures are based on hard-won experience. When we're operating 12 carriers simultaneously, we'll need new concepts for command and control, new radio procedures, new formation flying techniques. The conversation reflected a fundamental tension in American naval expansion. The industrial capacity existed to build carriers faster than ever before, but naval warfare required more than ships and aircraft. It required trained, experienced personnel operating as coordinated units under combat stress. Back in the flag plot, Halsey was reaching similar conclusions. Browning, send a message to SINCPAC. We need to establish advanced training bases where new carrier air groups can work up under realistic conditions. And I want experienced pilots rotated back to the States to serve as instructors. We can't just throw green crews into combat and hope for the best. The Marshall Islands raid proceeded successfully, with American aircraft inflicting significant damage on Japanese installations while suffering minimal losses. But the operation also highlighted the limitations of operating with only 2 fleet carriers against an enemy that controlled vast reaches of the Pacific. That evening, as the Enterprise Task Force withdrew from the Marshall Islands, Halsey stood on his bridge wing watching the sunset paint the Pacific in shades of gold and crimson. The successful raid had inflicted damage on Japanese installations, but it had also demonstrated the stark mathematical reality facing American naval forces. 2 carriers against an empire that stretched from Alaska to Australia. The numbers didn't add up. Admiral, Browning approached with a decoded message from Pearl Harbor. SINCPAC wants your assessment of the Kaiser production program for inclusion in their strategic planning. Halsey took the message form and considered his response carefully. His professional skepticism warred with his understanding of strategic necessity. Send this. Industrial expansion essential, but insufficient without parallel expansion of training capacity. Recommend immediate establishment of advanced carrier training facilities and rotation of experienced personnel to instructor duty. New ships require experienced crews, not factory workers with uniforms. 6 months later, on a foggy morning in July 1942, 2 very different worlds converged at the Alameda Naval Air Station in California. Maggie Sullivan, now a lead electrical supervisor with 6 months of carrier construction experience, stood on the dock watching the USS Hornet, the ship she had helped build, return from its historic mission to launch the Doolittle raid against Japan. The carrier's hull bore the scars of extended combat operations, paint faded by salt spray, antenna arrays modified by field expedients, and the subtle settling that came from months of high-speed maneuvering under combat conditions. But she was afloat, operational, and about to receive the new air group that would take her back into action. Lieutenant Commander Jimmy Thatch stepped off the gangway and was surprised to find a civilian woman waiting with official papers. Miss Sullivan, I'm told you supervised the electrical installations on this ship during construction. That's correct, Commander, Maggie replied, consulting her inspection checklist. We've had reports of intermittent communication failures during combat operations. I'm here to identify and correct any installation problems before your next deployment. They walked together through the ship's interior spaces, Maggie pointing out junction boxes and cable runs, while Thatch described the tactical situations where communication failures had occurred. During the Doolittle launch, we lost internal communication between the island and Damage Control Central just as we were launching the last B-25. It only lasted 90 seconds, but in carrier operations, 90 seconds can be the difference between success and disaster.
Maggie examined the junction box in question, immediately identifying the problem. Inadequate vibration dampening. The box is mounted directly to the bulkhead without shock absorbers.
High-speed maneuvering creates harmonic vibrations that work connections loose over time.
Can you fix it?
Thatch asked. Better than that, Maggie smiled. I can show your electricians how to prevent it from happening again. This is a design improvement we've already incorporated into the newer carriers.
Their conversation represented something unprecedented in naval history. Direct feedback from operational experience being incorporated into production improvements in real time. Traditional shipbuilding had been a one-way process. Ships were built, delivered, and operated for decades without significant modification. Kaiser's industrial methods allowed for continuous improvement based on combat lessons learned. The ultimate test of American industrial naval power came at the Battle of the Philippine Sea in June 1944. Admiral Raymond Spruance commanded Task Force 58, the most powerful naval formation in history, built around 15 fleet carriers that had been constructed in Kaiser's revolutionary shipyards. Among those carriers was the USS Lexington, CV-16, completed in just 16 months and commanded by Captain Felix Stump. Her crew included hundreds of personnel who had been trained in the accelerated programs developed to man the expanded fleet. Pilots with 18 months of training instead of 3 years. Sailors who would learn their trades in compressed courses that emphasized practical skills over traditional naval customs. Lieutenant George Blair, flying an F-6F Hellcat from the Lexington's deck, embodied the new generation of naval aviators. 22 years old, with 200 hours of flight training and 6 months of carrier operations, he was launching into the largest carrier air battle in history, with less experience than peacetime pilots would have accumulated before their first solo flight. But Blair also represented the advantages of American industrial production. His Hellcat fighter was superior to any aircraft the Japanese could field, faster, more heavily armed, and equipped with radar and radio systems that gave him tactical advantages his more experienced opponents couldn't match. American industrial capacity had compensated for limited training time by providing technological superiority. "All pilots, this is Air Control." The radio crackled as Blair's squadron formed up for the strike against the Japanese mobile fleet. "We have approximately 400 enemy aircraft inbound. This is what we trained for." The battle that followed vindicated both the skeptics and the optimists of American naval expansion. The new carriers and their air groups performed magnificently, shooting down over 400 Japanese aircraft while losing fewer than 50 of their own. But they succeeded not just through superior numbers, but through the integration of industrial production, technological innovation, and intensive training that had been developed over 2.5 years of wartime experience. Admiral Halsey, now commanding the 3rd Fleet from his flagship USS Missouri, received the battle reports from Task Force 58 with a mixture of satisfaction and amazement. The 15-carrier force had achieved tactical results that would have been impossible with traditional naval construction methods and peacetime training programs. "Captain," he said to his chief of staff, "send a message to Henry Kaiser. Tell him his floating factories just won the war in the Pacific." The message was unnecessary. Kaiser was already receiving reports from the battle through his network of liaison officers and technical representatives. The carriers built using his revolutionary methods had not only survived the test of combat, they had achieved tactical dominance over an enemy that had once seemed invincible. But the true measure of success wasn't just military. It was industrial. American shipyards were now completing a new Essex-class carrier every 6 weeks, each one incorporating improvements learned from previous ships and combat experience. The Japanese, with their limited industrial capacity and traditional construction methods, couldn't replace their losses fast enough to maintain the balance of power. By August 1945, as the war drew to its atomic conclusion, American naval power in the Pacific was overwhelming. The 15 carriers that had fought at the Philippine Sea had grown to more than 30 fleet carriers, supported by dozens of escort carriers, cruisers, destroyers, and auxiliary vessels that embodied the same industrial principles Kaiser had pioneered.
Maggie Sullivan, now Chief Electrical Supervisor for the entire West Coast shipbuilding program, stood on the deck of the USS Midway, the largest carrier ever built, as it prepared for commissioning. The ship represented the culmination of everything learned during 4 years of accelerated naval construction. Miss Sullivan, Admiral Nimitz said as he toured the ship before commissioning. This vessel and everything it represents is a testament to American industrial democracy. You and thousands like you have transformed not just naval warfare, but the relationship between civilian industry and military power. The transformation was complete. What had begun as an emergency response to Pearl Harbor had become a new model for national defense. The integration of civilian industrial capacity with military requirements to create strategic power that no traditional military force could match. The story of the Essex-class carriers and the Industrial Revolution that produced them resonates far beyond World War II. The principles developed by Henry Kaiser, standardization, prefabrication, continuous improvement, and the integration of civilian expertise with military requirements became the foundation of American defense industrial policy for the next half-century. Maggie Sullivan returned to teaching after the war, but she carried with her the knowledge that ordinary citizens, when properly organized and motivated, could accomplish extraordinary things. Her students learned mathematics, but they also learned that individual contributions to collective efforts could reshape the world. The Japanese had attacked Pearl Harbor believing they were fighting the American Navy as it existed in 1941. Instead, they found themselves fighting the American Navy as it became in 1943, 1944, and 1945. A force multiplied not just by industrial capacity, but by the democratic principle that free citizens working together could overcome any tyranny. Admiral Yamamoto had predicted that Japan could run wild in the Pacific for 6 months, but after that, American industrial power would become decisive. He was exactly right. The difference was that he thought in terms of traditional naval construction, individual ships built by craftsmen over years. He didn't anticipate Henry Kaiser and the arsenal of democracy, which turned shipbuilding into a manufacturing process and transformed American industrial capacity into the decisive weapon of the Pacific War. The carriers launched every 6 weeks from Kaiser's shipyards carried more than aircraft and crews. They carried the concentrated industrial might of a free society determined to preserve democracy against totalitarian aggression. Each ship represented the coordinated efforts of thousands of Americans who had never seen combat, but understood that their work in shipyards, steel mills, and training facilities was as important as any battle fought on distant islands. In the end, the Japanese had been right about one thing. Pearl Harbor was indeed a date that would live in infamy. But the infamy belonged to an empire that had awakened a sleeping giant whose productive capacity, technological innovation, and democratic determination would reshape not only the Pacific War, but the global balance of power for generations to come. The screaming dive of Commander Fuchida's torpedo bomber had shattered more than the morning calm at Pearl Harbor. It had shattered the illusion that industrial democracies were inherently weaker than military dictatorships. The arsenal of democracy had proven that free citizens, properly organized and motivated, possessed power that no empire could withstand. Thank you for joining me on this incredible journey through one of the most remarkable industrial transformations in human history. If you've made it this far through our nearly 50,000-word epic, you're clearly someone. I hope you found this story as fascinating to listen to as it was for me to research and create. These long-form, novel-length historical narratives take tremendous time and effort to produce. I spend weeks researching primary sources, interviewing historians, and crafting these stories to bring you the most engaging and accurate content possible. If you enjoyed Pacific Steel, the Arsenal of Democracy, please show your support by hitting that like button to help this story reach other history enthusiasts, subscribing to the channel for more epic historical narratives like this one, ringing the notification bell so you never miss our latest releases, sharing this story with friends and family who love compelling historical content, leaving a comment below telling me what part of the story resonated most with you.
Your support makes these massive projects possible. Every like, subscribe, and share helps me continue creating these detailed historical epics that bring the past to life in vivid, engaging detail.